Alrighty. So today we're going to talk about equations. The difference in what we're going to do today is that in the past we've just looked at one equation. This time we're going to solve two equations at the same time. So when you see the word linear, a system of linear equations, is we're going to be working with two equations at the same time, and we're trying to solve, looking for a solution for those particular systems of equations. So we got several methods that I'm going to show you. I'm going to show you the graphical method, and then there are two other methods, and then we're going to show you how it relates to real life. So with that said, here's the next slide. If I give you two equations, can you just type them in Desmos? Sure you can. Will they look like straight lines or uphill lines or downhill lines? Probably. In most cases they will. This is an example of two equations of lines, red line, blue line. Do they intersect? Yes. That is called the solution. Whatever point they intersect, that is called the solution. So that's what you're going to do with the next few slides. We're just going to find the solution for intersecting lines. Now, here's a question that I have for. If I give you an equation of two lines, do they have to intersect? No. What are the lines called that don't intersect at all? Parallel lines. So parallel lines don't intersect. So if I give you an equation of two lines that look like that, they're never going to intersect. So the solution for that would be what? I know it's interesting that you want to say zero. Zero is actually a point. So if you say zero, you're telling me they intersect at zero. So it would be no solution. If you have an equation of two lines that don't intersect, the answer is no solution. They don't intersect anywhere at all. So what if I give you an equation of two lines and then you only see one line? So again, let's try one so you can see. So let me kind of give you an example based upon the next slide what we're going to practice, what we're going to try to do. In solving for solutions of systems of equations, you could have one unique solution, meaning they cross somewhere, one point. That's one answer, one solution, if they cross each other. If they don't cross each other, there's no solution. And if they are the same line, it's infinitely many solutions. So let's look at an example of each one of those cases. You saw the first case. So go to Desmos for me, please. And let's do this first one first. Go to Desmos for me, please, and type those two equations in. One right after the other one. You don't need the squiggly line to the left. Just type the equations one right after the other one, just like you see it. Let me know when you got them both typed in. They should be in Desmos. You're typing them in Desmos. What should you see in Desmos? There should be crossing of two lines. You got it? Where they cross at? What's the point where they cross? That's what I want to know. Negative 1 and 1? Is that what everybody got?
No. I got a positive one. Hold on, wait.
I want the point where they cross. Where those two lines cross, and I want that point right there. Ah, that's what I want. 0.571, comma, positive 0.571. That's the point where they cross. It just so happens to be decimal numbers in this particular case. Okay, so is that one unique solution? Yes, because it only crosses at one point. Well, since you're in Desmos already, let's look at another situation. And so I'm going to look at, here's my Desmos. Let me open up a different screen for Desmos because I want to keep that other one we had. All righty, so now we're back in Desmos. I'm going to give you a different set of equations. What if I give you the equation y equals 2x plus 4? Here's my second equation, y equals 2x minus 3. Look at those two equations. What kind of lines are those? Those are parallel lines. Do they cross? Do they touch each other anywhere? No, they don't. So what's the solution for that system of equations? No solutions. So you can always look, oh, I can just type these equations in Desmos and it'll tell me that they don't cross anywhere. Well, what about that third solution? Remember, 1, they do cross. 2, they don't cross at all. The third solution, do they cross each other? Well, let's see. So let's give this example. Let's go back and I'm going to make up another equation. Let's say this is a 3. Let's delete this one. All right, that's my equation. Now, I'm going to create another equation. And can you see that that line is red, right? Watch this equation that I'm going to now put in here for this one. And let's see, here we're going to call it. What happened?
It's on the same line.
Aha. Did you notice before I put in my final number, did you notice that it had 2 lines at first? Did you notice at first there was 2 lines? At some point there was 2 lines. I'm just trying to see where I put it at. Did you see now you got a green line? But as I went to go add in more information, that you notice that the green line is on top of the red line. That's 2 lines. One's on top of the other one. So they really are the same line. Can you see that? Okay, so I'm just saying that will happen sometimes when you have equations and they say find the solution. So what's the answer for this one? They touch everywhere. Those lines cross, touch, lay on top of each other everywhere. So what's the answer? Infinitely many solutions. That's the answer. Infinitely many solutions. Where do they cross? Everywhere. Well, how do you write everywhere in math? Infinite, there's an infinite number of answers to that question. So you got to say infinitely many solutions. So you can have one solution, which is where they cross at one point. You can have no solutions, which are parallel lines that don't cross at all. Or you can have infinitely many solutions, which they are the same line, one on top of the other one. All right, questions? So far, so good? Okay, let me go back to the PowerPoint where we were again. Let's go to the next one. Your turn. Type those in. Tell me what the graphical solution is for those equations. You got 2 equations on the screen. Hello. Type both of those equations in Desmos and tell me where they intersect. Did everybody get the same answer? What's the answer that you got? 2, -2?
Yeah.
I want to make sure everybody got the same solution. Anybody questions about that? No. Okay, so this is how you do this graphically. You literally just type the equations in Desmos. It's going to tell you if they cross or not. Well, is there another way to do it? Yes, there's a manual way to do it. For testing purposes, you will be doing it manually. So let me show you how to do it manually, just so you'll know. But when you're practicing it for the homework, you can make sure you check your work. Go put it in Desmos and check your work and see if it's right. But here's how you do it manually. There are 2 other methods for doing it manually. One's called substitution, one's called elimination. So here's the next slide. So substitute. What does the word substitute mean? Think of it like sports. In basketball, when you say sub, what happens? You gotta take somebody out first, don't you? Yeah. You gotta take somebody out and put somebody back. Yeah. Put somebody back in. So they both gotta be the same value player. You take somebody out, put somebody in. Well, same thing here. We're gonna take something out, but in order to take something out, we still have to put something back in its place. You understand what I'm saying? That's what substitution means. Take something out and put something of equal value back in its place. So look at this next equation. All righty, here's my equation. We have 2x minus 3y equals 2, and I have y equals 5x minus 18. Now, of course, I could just go type these in Desmos and let it tell me where they cross at, right? But that would just be too easy, right? So let's show you how to do it manually. Manually says, I'm going to write the first equation again. And let me write it, space it like I want it. I'm going to rewrite the first equation. All right, so now, can you tell me what the value of the y is in the second equation? What's the value of the y? And I don't mean number value, just tell me what you see is the value of y. What's y equal to? That's what I'm asking you. What's y equal to?
5x minus 18.
Okay, so if you say y is equal to 5x minus 18, can I take the y out and put this in its place? Remember, it's subbing, we're subbing. Can I take this y, this number y out, or the variable y out, and put 5x minus 18 in its place? Yes. So that's what I'm gonna do. So here in the place of that y, I'm gonna put here 5x minus 18. Everything else is gonna stay right where it was. So in place of that, that's what we just put. Bless you. 2x minus 3 equals 2. Can you see I just subbed? So now we can solve and get x by it. So, all right, that's the goal. We just did our substitution. We're now going to solve and get x by itself. Can I distribute and multiply 3 times everything inside this parentheses?
Yes.
Okay, all righty. So I'm going to have 2x minus, what's 3 times 5?
15.
So that's going to be 15x. And then negative 3 times negative 18, what is that? Plus 54 equals 2. We're still solving to get x by itself. What do I do with the 2x minus 15x? I'll combine them. So 2 minus 15 is how much?
13.
Negative or positive?
Negative 13.
Negative 13x plus 54 equals 2. Minus 54 from both sides. So I've got what? Negative 13 is equal, negative 13x is equal to negative 52. All right, we're not done. Divide both sides by?
13.
So divide negative 13 on this side and divide negative 13 on that side. What's my final solution, my final answer? Okay, so x is equal to negative, is that negative or positive? Positive 4, okay. Now, we had 2 equations, right? Let me pull this down so I can push the other board up. We had 2 equations, 2 original equations, right? All righty. We want to know where they cross or intersect, right? So in order to say that they intersect, is it going to be a point that they intersect at?
Yes.
Okay, so do you have your whole point or you just got half your point? You just got half. I need the other part. So right now, I need to know I got x, comma, y. It should be a y. I want to know is 4, comma, what? 4, comma, what? We don't know yet. What you going to do with the 4 that you just figured out? We're going to plug it back into what? Either one of, in the x, but for either equation. It don't matter which equation you pick. Whichever one looks the easiest for you to work out is the one I always plug in. So I'm going to pick the second one. Because it's already got y by itself, so I'm going to pick the second one. So I'm going to plug in everywhere there's a x, what am I going to put?
4.
A 4. So where there's an x, I'm going to put a 4. So I've got y equals 5 times 4 minus 18. There's my 4. What's 5 times 4?
20.
All right, and what's 20 minus 18? So y equals what?
2.
What's the point where those 2 lines cross?
4, 2.
4, comma 2. That's your solution.
Check it out.
Now you can go to Desmos and put that same thing in, and it'll show you that 4, comma 2 is where they cross. What method was this called? Substitution method. So if you're looking to see what is this called, this is my substitution method. For testing purposes, you can use whatever method makes you happy other than the computer. So you got 2 methods that you can choose from. It doesn't matter what the test says. If it says substitution and all you remember how to do is elimination, that's perfectly fine. So you'll have options of which method you prefer. All righty, questions? Okay, so that was our first method for how to do this. And let me put x equals 4 right here. So I can erase and use this other board. So I'm going to push this up here so I can do the second method. All right, here's our second method. Well, actually the third, since you already know how to do it graphically. You know how to do substitution. Now let's do it using method called elimination. So this is our next method. Next slide. This is called the elimination method. Now, what does the word eliminate mean? Cancel or get rid of it. I don't want to see it no more. Eliminate it. Okay, so that's what we're going to do. In this particular case, we want to eliminate or get rid of either all the x terms or all the y terms? You don't want to see all of the x's or all y. Pick which one you want to get rid of, but you got to get rid of one. So here we go. All right, here are your equations. Can I just go type these in decimals if I want it to be easy? Of course we can, but we're going to do it the long way. We're going to do it the long way. All right, so you've got two equations. 4x minus 3y is equal to negative 13. And then you've got 5x plus 6y is equal to positive 13. All righty, elimination means find a way that you can multiply one of these equations by something so we can eliminate the y's or the x's. So what I'm going to do is I'm going to multiply this top equation, everything in the top equation, by a 2. Why do you think I picked 2? So if I multiply 2 times 4, that gives me 2 times negative 3 gives me, wow, wouldn't you know, what's the negative 6 and a positive 6 is going to cause them to disappear. So hold on, let me go ahead and multiply so you can see. So I've got 8x minus 6y is equal to, what is that, negative 26? All right, I didn't do anything to the second equation. We didn't touch it. So I'm just going to rewrite the second equation just like it is. So rewriting the second equation just like it is, you end up with 5x plus 6y equals a positive 13. Draw a line underneath both of those equations. Now, add or subtract vertically like you would if you were doing kindergarten math. Alrighty? So, if I'm adding or subtracting vertically, in this case, is this positive and that's positive? So, 8 plus 5 is? Alrighty, so this is going to add to be 13x. Well, what happens to this negative 6y and the positive 6y? They cancel out because that's just 0, so they disappear. So we don't need it anymore. Have we just eliminated something? Yes. That's our goal. We want to be able to eliminate either all the x's or all the y's. We've just eliminated all of our y's. All right, what's left on the right side of the equal sign? Negative 26 and a positive 13. How much is that?
Negative 13.
Negative 13. Divide both sides by?
13.
Okay. So x is equal to? Negative 1. Okay. Do I have my whole point for where they cross? No, you just got half. What do I do with this negative 1? Substitute it back into either one of the original equations. Now, at this point, does it matter which one? No. So I'm going to go plug this in. So this should say plug in. And I'm just going to pick the first equation. All right, so I got 4 times negative 1 minus 3y is equal to negative 13. What's 4 times negative 1? Okay, so that's negative 4 minus 3y equals negative 13. Add 4 to both sides? Add 4 to both sides. So the 4's right here cancel out. Let me push this up so you guys can see. And now I've got negative 3y is equal to what? Negative 9. Divide both sides by?
3.
Negative 3 or positive 3? Negative 3. So y is equal to 3. What's the point where those two lines cross? This is your solution. This is the word they're going to be asking you for. What's the solution?
So you always use 2, like when you divide, multiply?
No. You got to figure out what number to use that's going to help you get rid of that 6. So it just so happens I saw that was a 6, and I was like, oh, if I multiply that by 2, these two get eliminated. So you got to figure out what number to multiply by. Yeah.
Do we always have to start with the y?
No. You can pick whichever one. So because you said that, I'm going to do this problem, same problem, but now I'm going to do it a different way, using different numbers to multiply by. So let's say you didn't want to eliminate the y's. You want to try a different, that same problem. I'm just going to do it a different way. So I'm going to rewrite the problem again here. So I still got 4x minus 3y equals negative 13. And 5x plus 6y equals positive 13. I am going to multiply both equations by something. You're like, well, why should you do that? Because it just so happens I saw the 2 and the 3 would work with this one. But what if there wasn't a 3? What if that was a 15? Then you're like, well, what am I going to multiply by? So then I'm going to look at these two numbers in the front. I'm gonna multiply this front number right here, excuse me, not the front number, but the first equation, I'm gonna multiply it by -5. The whole equation by -5. The second equation, I'm gonna multiply by a +4. Can you see why I did that? Well, think about it for a second. What's -5 times 4? -20, and what's 4 times 5? +20. Then what happens? All of my x's get eliminated. So you see what it is? Whenever you decide, and you can do this every single time, if you want to use the elimination method, you're like, look, whatever number's up here, I'm going to multiply down on this equation. Whatever number's down here, I'm going to multiply by the top equation. Always you can switch them, and that will work every single time. The only thing is one of them got to be positive and one has to be negative. That's the only way they cancel out. So now let me rewrite my new equations now that I've multiplied both my equations. So I've got a -20x and -5 times -3 is +15 equals -5 times 13. Is that +65? Somebody check my math. Second equation, the new equation is going to be 20x plus 24y equals 52. All right, those are your new equations. I'm gonna vertically add or subtract up and down. So again, this got a -20 and a +20. Can I cancel those -20 and +20 out?
Yes.
Okay, so that's gone. What's left? I'm gonna add 15 and 24, which is 39y. And now I've got a +65 and a +52, which is 117. Divide everything on both sides by 39. And over here on 39, and what's my answer? Y equals 3. Well, didn't we get 3 over there when we did it the first time? Yes, and if I plug it back in, can I plug it into either equation?
Yes.
Plug in, doesn't matter which one. So I'm gonna take this first one again. 4x plus, or not plus, but -3y minus 3 times, I got a 3 here that I'm plugging equals -13. So you can see 3 times 3 is how much? 9, okay. So I got 4x minus 9 equals -13. Add 9 to both sides. The -9 and the +9 cancel, so you're left with 4x equals, what is that, -4? Divide both sides by 4, so x is now equal to a -1. Is that the same solution we got? That works every single time. So again, I'm just telling you this because if this number's a 5, you put it up here. If that number's a 4, you can put it down here and just make sure one's negative and one's positive. Now, here's my question. What if there was already a negative sign on that 4? Would you have put a negative here?
No.
No, because it's already negative. So you don't need to put a negative unless neither one of these are negative. Then you would need to use a negative. Okay? What method was this?
Elimination.
This was the elimination method. Again, for test purposes, whichever one you like is the one that you can use. In order to use the substitution method every single time, even if you have equations like this, if you wanted to use the elimination method, you can, but you got to get x or y by itself, one of them. When should you always use the substitution method? In the equation where it already gives you x or y by itself, you want to use the substitution method. So wherever you see x or y by itself, it's always easiest to use the substitution method. But if you like it and you want to use it for everything, then you got to solve and get x or y by itself before you can use it. Questions? All right, real life. All right, let's read and see what we got. A jewelry maker has total revenue for her bracelets given by R equals 89.75x. Why should you use R? Revenue equals, so the revenue equals 89.75x, and she incurs a total cost of 23.50x plus 1192.50, where X is the number of bracelets she produced and sold. Use the graphical methods to find the number of bracelets that gives the break-even point. Type them both in Desmos and see where they cross. Go. Type both equations just like you see them in Desmos and see where they cross.
You don't have no Wi-Fi right now. Yeah, you're not connected to the internet yet. See, well, this one says, you still should be able to use your, here, cashier and use your own, Play State, I do everything. Okay, so now it's connected, now go back and, you're in Google now. Okay, yeah.
Alrighty, were you able to type both equations in Desmos just like you see them on the screen? Literally type R equals 89.75x and C equals 2350x plus 1192.50. Did you get someplace that they actually crossed? Where they crossed at? Tell me the point where they crossed at. You should have a point. So 18 what?
18, 1615.5.
1615. Okay. Alrighty. Remember, the X is the number of what? What's the X in this case? X is the number of what? What is? Okay. Wait. What is that up there? What does it say X is?
The number of bracelets.
Oh, okay. So remember, this is always your X comma Y or whatever letters they use. They use X, and what other letter did they use? Let me see if they gave us. We got X for input, and in this particular case, it's going to be the same for either C or R. So this could be C or it could be R. Why is that the case? Let me talk about it for a second. All right. So here is X is the number of what?
Bracelets.
It's the number of bracelets. What was the question they asked us to figure out? What did they ask? What was the question? You got to always make sure you understand what did they ask you to go do.
How many number of bracelets
Is the break-even.
Well, what does break-even point? You can't even begin to do this if we don't know what break-even point means. What does break-even point mean?
It means when she is making as much as she put in.
Okay, so the same amount of money you spent is the same amount of money you made. You understand? Break-even means I ain't lose no money, I ain't make no money. I'm at zero. Do you understand what that means? The same amount of money it cost her to make the bracelets is the same amount of money that she made when she sold some bracelets. That means that those numbers are the exact same. So here, you have to take both equations, see where they cross. That's the break-even point. How many bracelets does she have to make and sell to break even? 18. And how much money is she gonna make? $1,615.50. And how much money did she spend?
The same amount.
Same amount. Remember, break even means what you made and what you spent is the same. You understand what I'm saying? Y'all not responding. I'm trying to make sure y'all understand. Do you understand that the same amount of money you spent is the same amount of money you made?
Yes.
Okay, so I made these bracelets. It cost me $1,615.50 to make these bracelets, or order them, inventory, however you got them. And then I made $1,615.50 when I sold them. So that's a break-even point because you ain't got no money left, but you don't owe nobody no money either. You understand what I'm saying when I say break-even?
Yes.
So the break-even point wants to know, find the number of bracelets that's the break-even point. The number of bracelets was what?
18.
Did it want this number over here?
No.
Did it ask you what's the break-even amount in dollars? Did it say what's the break-even amount? No, it didn't say that. It said how many bracelets gives you a break-even point. So they break even at 18 bracelets. Okay, well that's a good thing because now when do I get into profit mode?
19.
At the 19th bracelet, I am in pure profit mode. 19, 20, 21, over 18, we are in profit mode. Does that make sense? Okay? So did we just use the graphical method for what we did? Could I also have done it using the long write it out by yourself method? Yes, we could have done the exact same thing. Question. All right, next one for you to try. Let's read it. A manufacturer of reading lamps has a total revenue given by R equals 15.80x and a total cost given by 8593.20 plus 3.20x, where x is the number of units produced and sold. Use the non-graphical method to find the number of units that gives the break-even point. They want to know how many reading lamps do you have to sell or produce to give the break-even point. Alrighty? What method am I going to use? Okay, so I got two equations. R equals 15.80x, and then I got C is equal to 8593.20 plus 3.20x. All right, so now they've left the R and the C by itself. Can I use the substitution method?
Yes.
Yes, what should I do if I'm doing the substitution method? Okay, so can I replace the C with the 15.80x? Remember, in order to be break even, do the revenue and the cost have to be the same? Yes. So in this case, whenever you see the word break even, this is what it means. These two, revenue and cost, are the same. So I'm going to put that word here. Revenue is equal to cost for break even point. Okay, so revenue equals cost for the break-even point. So can I replace this C with 15.80x? That's my substitution. I'm going to take the C out and put 15.80 in its place. Alrighty, so here I'm going to put 15.80. X is equal to 8593.20 plus 3.20x. My goal is to get x by it. Okay. Should I subtract 3.20 from both sides?
Yes.
Okay, subtract 3.20x from over here and 3.20x from the left side. On the right side, 3.20 and minus 3.20 cancel themselves out. So I have, what is that, 1260? 12.60x equals 8593.20. I need a calculator, somebody. Okay, 8593.20 divided by 1260. I got to divide by 12.60 on both sides. Okay, what's the answer? 32? 82. All right, what was the question? Yes, ma'am.
It's
682. 682? Okay, thank you. Did y'all all get 682? Okay, I didn't hear the 6. All righty, so here's the question. What did they ask us to find?
Find the number of units that
The number of units. Do I want dollars or units?
units.
I want units, so am I good with that answer right there?
Yeah.
Yes, is this units or dollars? This is units. This is how many reading lamps you sold. Those are units. So, what gives me the break-even point? I gotta sell or create 682 reading lamps in order to have a break-even point. Questions? All right, you good? All right, well, here is the last one for this section. Everything that you usually see on the board here that I do, you will see something very much like it in the homework. There is one exactly like what you see on the board, on the screen in the homework. Exactly like it, except they've changed a couple of numbers, but the problem is exactly the same. So, what questions do you have? Can I erase one of these boards? Can I erase the substitution method? Okay, all right, erasing the substitution method. Now let's see if we can actually work this one out. Now, before we work it out, I need to make sure you understand what's going on, the topic of conversation for that word problem. So let's read it and make sure we understand the topic. It says a certain product has supply and demand functions, meaning supply and demand equations, which are given. The first equation is your supply equation, and your second equation is the demand equation. How do you know that? The word respectively. It tells you just to label them in order. So the first equation, P equals 5Q plus 20, is your supply equation. And P equals 128 minus 4Q is your demand equation. You okay? We're okay with that so far? Now let's talk about what does supply and demand mean. And I know it's about economics, so let me just give you my little spiel on making sure we're on the same page with what it is. Supply usually means how many we have on hand, or how many we have in inventory, or how many we have on the shelf. You on the store, you're on whatever it is, that's your supply. It's like at your house, how much supply you got of Frosted Flakes in your pantry? What's your supply? Milk in the fridge, you have a supply, but from a store's perspective, don't they have a supply of whatever they sell? Shouldn't they have a supply of it? Okay, all righty. Now, what's the demand? That's where you and I come in. Don't you want stuff from the store? My kids do. Like, can we go to the store? Everything is about going to the store. So, don't you want, as a consumer, aren't you buying stuff from the store? So, does the price affect whether you're going to buy it or not? Yes. If the price goes down, do you run out and get some more? Yes. Of course we do. The cell phone 8, 9 come out and it's $100. How many go and buy one for $100? I'm just saying. I'm just saying. So all the little high schoolers will definitely want the next, because my daughter thinks she's supposed to have the latest and greatest of whatever phone comes out. But that's the point. If the price goes down, are we going to buy more? Yes. Usually we do. So that's when we say the demand is greater if the price is lower. Is the demand higher if the price is higher? No, we typically don't want to buy it if the price is higher. So again, that's just to kind of give you just a little bit of an idea of what supply and demand actually means. Okay? So we okay? We understand the topic of conversation. All right. So now the first bullet says if the price is $60, we don't even know what the item is, but the price of it is $60. If the price is $60, how many units, which we're calling Q, quantity is Q. Q means quantity. It says how many units Q, or how many do you have in your quantity, are supplied, and how many are demanded. Okay, let me go ahead and figure this out so we can see if we're on the same page. We know what the price is. They just want to know how many you're going to have on hand on the shelf, and how many are we going to be demanding as consumers if the price is 60. You got it? Okay, so now I got two equations. My first equation was my what?
Supply.
All righty, which is what?
P equals 5Q plus 2.
Okay, what was my demand equation?
P equals 128 minus 4Q.
128 minus 4Q. Okay, all righty. What did they say the price was now in bullet number 1?
60.
And they want to know what the Q is. What's the quantity? All right. So here, I'm going to plug in the place of the P. What number should I put?
60.
Okay, so I'm going to put a 60 in the place of the P because they told me P is $60. So I got $60 right here equals 5Q plus 20. Do I solve and get Q by itself? Yes. All righty, so solve, I'm going to subtract 20 from both sides. All righty, the 20 minus 20 cancels. Alrighty, I end up with 5Q is equal to, what's 60 minus 20? 40. Do what to both sides now? Divide by 5 on both sides. So now, Q equals, alright, what did we just figure out? When the price is $60, we have how many in supply? 8. Okay, now let's do the same thing with the demand equation. So I'm going to put 60 in, $60 in for my price. And now I want to subtract 128 from both sides. Is that right? So now I end up with 60 minus 128. Is that negative 68?
Yes.
Equals negative 4Q. Divide both sides by negative 4. Okay, so if I divide both sides by negative 4, Q is equal to what? What is it, what y'all say, 17? All right, 17. All right, so when the price is 60, how many are we asking for to be on hand? We demanding that they have? 17. Okay. So now you've just answered bullet number 1. Bullet number 2 says what?
What price
Is market equilibrium.
That word equilibrium is the key. When you see the word equilibrium, I want to know what's the price when those two equations are equal to each other. What's the price for when we're going to set both of those equations? Word equilibrium, set both of those equations equal to each other. That means we're actually using the substitution method. So I'm saying, don't you have a P and a P here? Don't there 2 P's? Can I replace and put both of those P's together and have one long equation? Yes, that's what we're going to do first. So you've got 5Q, set both equations equal to each other. When you hear the word equilibrium, let me make sure I spell it right. Set both equations equal to each other and solve and get what by itself? Get Q by itself. Alrighty, what should I do first? Add 4 or minus 5Q from both sides? Add 4Q to the right side, add 4Q to the left side. And I end up with 9Q on the left plus 20 equals, all right, subtract what? Minus 20 from both sides? Alrighty. So that leaves me with 9Q is equal to 108. Divide 9 by both sides. So if I divide 9 on this side, divide 9 on that side, Q is equal to 12. So, is that the answer they were looking for? Is that the answer they were looking for?
Yes.
Look at what the word says in the first 2 words.
What price?
Did we find a price?
No.
We found a quantity. Remember, Q is quantity. So we found a quantity. What does it want us to do? Find a price. So we got a Q. What should we do with the answer that we just found? Plug it back into either one of the first equations. It doesn't matter which one, because we're looking for a price, right?
Yes.
Now, what was the 12 representing anyway? It's the market equilibrium quantity when those two equations are the same. We don't want the equation quantity, we want the equation price. So now, I'm just going to take the Q and plug it in to either equation. So I've got 5 times 12 plus 20, so that's P equals. So now what's 5 times 12?
60.
So, and 60 plus 20? So, what's the market equilibrium price? $80. So, all that says is, when the price is $80, the demand is for how many? 12. And when the price is $80, the supply is how many? 12. So, you done? That's when both numbers are equal to each other. The supply and the demand are both equal to each other. When the price is 80, your demand is for 12. Y'all saying I want 12, and the supply at the store is 12. When the price is 80. That's market equilibrium. Questions? Y'all good? That's what the homework is going to ask you to do. Let me stop this before.